Hello, and thanks for joining us today for the Twitch talk on mail and messaging capabilities in version 12 of Wolfram language. Email is still a very important and common way of communication for people these days. In version 12, we have expanded our capabilities to access mailboxes, import emails, and also send emails and messages. Today's Twitch talk is going to go through ways of connecting to IMAP servers, flag move individual emails, work with email folders in an email server, easily search for emails, import different elements of emails from Mbox and EML formats, and also some other updates in send mail and send message. Examples that we have provided are grouped into basically three main sections. The first row is going to be on connecting to mail servers and working with individual emails or folders, which my colleague Fahim is going to be presenting. The second row is basically accessing different elements of emails via import in order to statistically analyze what's going on in a mailbox. And then the last row is going to be examples on send mail and send message. With that, I'll hand off the screen to Fahim to start with Mail Server Connect.
Hi, Fahim here. So I worked on writing IMAP link, which is the underlying protocol for mail server connect, mail search, and executing different commands on the IMAP server. So with 12.1, we were able to connect to a mail server, a live one. So this is an example of connecting to the Gmail because they provide an IMAP protocol connecting to Gmail through IMAP protocol. So here's an example of mail server connect. And you can get the list of folders you have in your Gmail. We introduce mail folder object, and you can also get certain properties from that mail folder object. And here's an example where the unread message count, so how many emails you have that you haven't read. Then after you are able to connect, then you can read mail messages, and there it is connecting, and to the inbox. Once you have the mail folder, you can extract messages from the folder. And so and you can use the part syntax, kind of part in syntax. So -1 will give you the last email, and it returns a mail item which is decorated like this. That is an icon. I think this might change in the future, and all this functionality currently is experimental. So once all the kinks have been sorted out, we will promote it to normal class of functions. And here's an example where you can ask for a body. So this is a test in this example. And then it is also possible to search mail messages. This is an IMAP search. You can't, this is not a local search like what happens in your local email client. So the syntax for that is available in the documentation, but here's an example where you're searching for subject hello, and it returns, mail search will return a data set, and this is the syntax is for a data set syntax for getting the first item and the column mail item. So first row and mail item, that's the example here. Then you can execute stuff. You can create mail folders, and here's an example for that. Things that users usually do in the user interface, like on Gmail, create folders, mark email as read, unread. So here's an example for creating a folder, and then you can copy the items that you have searched for, and then you can just copy them to another folder. So that's the example over here, and you see this once it's copied is in a different folder. So I think now if I go back, all of this mail item is what Shadi will talk about, is built upon the EML import export features. So we use our language to build this mail item. The mail server connect is also using some other underlying libraries, which some users would know about, but if there are questions, we can answer those. Yeah, so that's, I'll hand this off to Shadi now. Shadi, do you want to take over?
Sure.
No.
Thanks. Okay, so yes, a lot of that is built upon EML and MBOX, which are formats that we have been supporting in the language for a while now. Version 12 expands on those capabilities for importing EML, which is typically a container of a single email, and MBOX, which is a collection of emails in one file format. So examples here show importing of a single EML file, a single element of that, or something like a message summary, which includes the sender, the recipients, and some other information such as subject, body, whether it has an attachment, and so forth. When it comes to MBOX, as I said, since that's a collection, we can ask for how many messages are included in that MBOX file, in this case, 13. And this is basically just enumerating through those basic information, such as sender, recipients of those 13 emails in the MBOX. So this is basically just the beginning, saying that we have MBOX EML. This is improved slightly in version 12. The rest of the examples in this row of 4 is basically showing how now we can use all of the import capabilities to perform some analysis on the mainly on MBOX, because that's become the more interesting part, where we have a collection of emails. So some just random examples, in a sense, to give a clue about what are the types of things we can do. For instance, here we're importing all the subjects of emails, including in an MBOX. From those subjects, we are splitting them and passing them on to word cloud. So this is a very quick visualization to show what are the topics, or the range of topics that have been discussed in that mailbox. Another tag, for instance, could be in originating date passed to date histogram, so that we know what's the lifespan of that mailbox. When did it start? When did it end? And when was it more active? Or, for instance, we can reduce the dates to hours of the day, time of the day, and this is another date histogram that says around noontime, or sometime between 9 and noon is when we have peak of emails sent to that MBOX. This is, again, a very small mailbox, or maybe no, this is not a very small. I don't know how many emails, but this is not what we have in example data. So this is still not a very tiny MBOX, but can be used with any size of an MBOX file. Another type of analysis, for instance, we count how many times a person has sent an email in that mailbox, and we can do another list plot while sorting with the number of emails sent by each person. Here we have iconized people by little graphics with different colors showing different people in the MBOX. So the person who has sent most emails has been 30-something emails, and there are people who have just sent a few emails in that MBOX. Another example that is now doable is analyzing email threads. The way threads are recognized in an inbox is by looking at message IDs and reply to message IDs. So whenever an email is a response to an email, the tag reply to message ID gets stored in that email. So basically, we can understand the connection between emails in an inbox using just these two tags. But we're getting a few more tags so that we can use them in the process that is shown here. So with that information imported, we extract message IDs, select all the messages that are replies to one another, create edges between those, basically create nodes, graph nodes out of all of the messages, create edges between two emails that one is a response to another one, and basically construct the conversation graph like here. So we have message vertices, we have all of those message edges that are connections between two messages, and that's our graph. Some emails in that mailbox have never been responded to. Some emails have single replies, and some conversation have gone bigger, like that first subgraph that we see on the left. So this is a very good start for our conversation or thread analysis. Something else we can do, remember we got originating date imported as well. So now we can look at originating date of all of the emails in a single thread. And by passing that to timeline plot, we are basically seeing the lifespan of a single thread. So for instance, that longest conversation have started sometime early December and ended around January 1st. Again, we have conversations or emails that got never responded to, so they are single times in that timeline plot, or conversations that have lasted for a very short time. Making that one step further, we can use other tags such as subject, as well as those start and end times, to add tooltips or labeling function into all segments in that timeline plot. So this is basically showing a subject, start, and end time of that single conversation in the inbox. And one last example there is now digging into a single thread and showing a timeline plot with all of the messages in that one thread from the mailbox. So the thread chosen here, which is the first of the threads, has 3 emails in it. We have put all of them on the timeline plot with a little tooltip or label that shows the new content that was added. So this is the first email. The second email, that's what has been responded. That's the new body content that is being displayed. And that's the last email in that thread. Thread analysis can get more interesting. This other example analyzes relations between email senders. So this is basically the same graph we have created in the previous example. In this example, now we are using from address, and again, constructing a graph. However, this time we are constructing a graph where vertices are individual people in the inbox, and joints between those vertices are whether one person has responded to another. So 2 people in the graph are connected only if one of them has responded to another person. So if there is a link between person 1 and person 2, that means there has been an interaction. If there is no link, there has been no interaction. None of them has responded to another. This is an indirected graph. Obviously, we can make this a directed graph as well. So this basically shows the connectivity of people in the inbox. With a little bit of extra work, we have weights for how connected is an individual to all the other people in in that particular mailbox. And also we are showing how strong is a connection between 2 people in the mailbox. So in this case, the size of the vertices is showing the connectivity of the person to other people. So a person with more connections is shown bigger using the vertex size. that is computed from the number of conversations he or she has had with other people. And again, the weight or the edge shape is specified by the number of replies that two people have had in that mailbox to each other. Okay, this concludes the analysis that we can do by accessing mailboxes. Another set of capabilities that we have had again in the system for a while and we have improved on is sending email. There is a lot of computation that can be done in the Wolfram language. We would like to reach out to other people by sending them email directly from within Mathematica or the Wolfram language. There are some advanced mail settings, including auto BCC, auto CC signature that can be accessed through preferences in internet and mail settings. Incoming mail settings is for what Fahim talked about earlier, or for mail receiver function and things like that. And outgoing is specifically for send mail. There is also a mail settings option in send mail that can be programmatically specifying those advanced settings, such as auto BCC and signature in this example. And with that, this is the email that reaches the recipient. The signature is there. The auto BCC is not shown, but the sender as well gets a copy of that in his or her mailbox. Another big aspect of improvements in version 12 is sending rich Mathematica objects in email using attachment. For instance, dataset in this example is automatically being exported as a CSV and attached to the file. So here we just have a dataset, a regular dataset, could be any dataset with more columns, more rows, not more dimensions in this particular case, because CSV, or if it has more dimensions, every one of these elements is going to become a list. However, the dataset gets converted to CSV and then sent as an attachment. Obviously, the dataset can be explicitly exported to a CSV that lives somewhere in your file system, and then using file attachments can be attached to SendMail as well, which is an option that SendMail provides. Another example is an audio object in Mathematica, which is created in this example using speech synthesize. The audio object is automatically converted or exported to a WAV file attached to an email. This is a typical display. You typically get an audio player in your mail viewer when you have an audio file attached. Send message, another function that has improved in version 12, has SMS and MMS channels. This is an example that searches the web for a specific query, right? For instance, in this example, astronomy picture, gets one random pick out of those results, and then send it as an MMS to your previously set mobile number, which is that dollar mobile phone. The same procedure is now packaged under a scheduled task deployed on the cloud. So the procedure is happening on a daily basis. The web gets searched for images of astronomy pictures. One is randomly selected and sent to your phone number as an MMS. Send message also has a Twitter channel. This example shows a simple example. We are performing a computation like next prime and computing the timing of that. Then the string says it only took my computer so many seconds to compute the last prime before the number. Could be anything. And then it's tweeted out. And this is the result that is going out to Twitter. That concludes the examples of this product page. At the very bottom, related functions, related guides, which are going to show you more examples of the kind, and related links to previous product pages, version 11, as well as other product pages that might be of interest or related to this mail and messaging set of capabilities. Thanks. Any questions we need to respond to, Fahim?
Yes. there was this question about, will this work with Google's ever-evolving IMAP implementation and extensions or Apple's IMAP servers? The short answer is yes. The long answer is that with Gmail, now IMAP only works with a username and password, so Gmail considers it a bit of a security risk getting your email through IMAP protocol. And so in the first go, when somebody tries to do mail server connect imap.gmail.com, the user will have to go to the web interface on gmail.com, go to the configuration settings and say allow IMAP. And from then on, it should work. I do not know if Apple has the same limitations in which a user actually has to manually allow access to it. But Gmail will prevent you initially, and then you can say, no, I know the service is fine and it should work.
Okay. Thank you very much. Thanks for joining us on this Twitch. Let's close it here. Bye.
Bye.